So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on the speed of sound. So let's begin with the worksheet. So here is the worksheet on speed of sound. So the first question is speed of sound in a solid. So it is given by root of E by D, where E is the elasticity coefficient. And for solid, this is given by the Young's modulus. So the speed comes out to be root under Y by D as far as solid is concerned. Then speed of sound in liquid. So in liquid, elasticity is given by the bulk modulus, and for a gas also elasticity is given by the bulk modulus. So in liquids as well as in gas, speed of sound is root under B by D. Next is speed of sound in air. So it is approximately 332 meter per second, and which is given by root under gamma RT by M. Next question is graph between V and gamma. Gamma is the adiabatic exponent. So we can see that V is proportional to root gamma. So the graph will be a parabola here. Next is if we draw graph between V and T. So we can see that V is proportional to root T. So the graph again will be a parabola. However, if we draw graph between V and root gamma, so that will be a straight line. As well as the graph between V and root T, that will also be a straight line. So these are the possible graphs. Let's now move on to the next set of questions. So here graph is between V and M. So V is proportional to root 1 by M. So it has a shape like rectangular hyperbola. Then is graph between V and root M. So we can see that V is proportional to root 1 by root M. Let us take this as X. So the graph will be a rectangular hyperbola here. Next is speed of sound in oxygen at T Kelvin is V1. Then find speed of sound in hydrogen at T Kelvin. So as temperature is same, so V is inversely proportional to M. So V1 by V2 can be written as M2 by M1. Here 1 is for hydrogen, oxygen, and so here 1 corresponds to oxygen and 2 corresponds to hydrogen. So using V1 by V2 is root of M2 by M1. We have as root 2 by 32, which is root 1 by 16, which is 1 by 4. So from here V2 comes out to be 4 times V1. Next is ratio of speed of sound in hydrogen and oxygen. So as we have calculated, V2 by V1 is equal to 4 over here. Next is at what temperature hydrogen has same speed of sound as that of oxygen. So using the relation V1 by V2 is root over T1 by T2 into root over M2 by M1. Since speed is same, so we take V1 by V2 as 1. So this is equal to root T1 upon T2. T2 as we have taken for oxygen, and the temperature here is T, into root 16. So we can say that, so on squaring the terms, we have 1 is equal to T1 by T into 16. So from here we can say that T1 is T by 16. Next is if temperature increases by 4%, find percentage change in speed of sound. So from the relation V proportional to root T, we can say that percentage change in speed is equal to half percent change in temperature. So the temperature increases by 4, so we take percent T as 4. So the answer comes out to be 2%, which shows increase in the speed. Next is temperature is decreased by 4% change in speed of sound. So if temperature decreases by 4%, we take percent T as minus 4. So answer will be minus 2%. Next is temperature is increased by 21% change in speed. So as V is proportional to T, so we can say that V2 by V1 is root T2 by T1. So temperature increases by 21%, so we can say that T2 is 1.21 times T1. So that comes out to be 1.1. So from here we can say that V2 is equals to 1.1 times V1. Next is change in speed is, so percentage change in speed is V2 minus V1 by V1 into 100. So that comes out to be 10%. Now is sound has maximum speed in, so it has maximum speed in steel, as steel is ideal to close to ideal rigid body. Next is sound has minimum speed in gases. Next is speed of sound in oxygen at 27 degrees centigrade. So using the formula root gamma RT by m, it is about 330 meter per second. Next is speed of sound in hydrogen at 127 degrees centigrade. Using the above formula, the speed comes out to be about 1520 meter per second. Next is a container contains 2 moles of helium and 3 moles of hydrogen. We need to find the average molecular mass. So average molecular mass is N1 M1 plus N2 M2 by N1 plus M2. Using this we have 2.8. Next is speed of sound in helium. So V is equal to root gamma RT by M. So that will be M here is 4. So we can calculate that. Then in hydrogen again we can calculate using the same formula. Then ratio of speeds, it's come out to be root 10 by 21. Then speed of sound in mixture. So we take gamma as gamma equivalent and molecular mass as equivalent molecular mass. So in this way we can calculate the speed of sound in a mixture of gases. So you have seen that these are the optimal physics worksheets, and these are designed with the pattern to optimize your time and energy and to make sure that your mind brain system has optimized according to the requirements of the exam. The thing is that any competitive exam like JEE and NEET, they are based on psychologically designed mental patterns, and you can crack these exams if you have those inbuilt decoding mechanism. You have learned the neural patterns given in the books, given in the standard information, and have converted them into patterns. Those patterns are needed to crack competitive exams. So these worksheets are just a testing mechanism to make sure that are you working as per the requirements of exams or just working in any haphazard way. So use these worksheets as a testing mechanism, and these are the very simple worksheets which tests your working at the very basic level, very fundamental level. And soon we will upload higher level worksheets to ensure that up to what level you are prepared for the exam. Thank you and have a nice day.